Hey everybody, happy Thursday. Hope you are having a great week so far. It is Thursday. It is time to explore the softer side of hardware here on the stream. My name is Brandon Satrom. I am a developer. I do IoT work. I do software work, web work, really all over the map. I by day work for Particle, an IoT platform company. And on these streams, I typically will do hardware work on Tuesdays, and on Thursdays, we'll spend some time doing firmware, software, app development, all those kinds of things. So the current project that I've been working on for the last couple of weeks, I started last Tuesday, continued this Tuesday as well, is the BrewBuddy. BrewBuddy is a homebrew monitoring solution, something that I created a couple of years ago and built based on the particle photon. That's actually here in the upper right-hand corner. And I decided several weeks ago that I wanted to port it over to the Particle Argon. So Particle's new third generation hardware, just as a standalone device, not doing any mesh networking with it yet, although that certainly is possible with a fleet of these kinds of devices. So we did sort of the prototyping piece last Tuesday, or Tuesday before last, and then a few days ago, as you see on my screen, I actually created a new board with Eagles. So did the schematic updates, added a NOx sensor to detect fermentation, and then built out the board. Not a super terribly exciting board, but hey, you know, it works. It's still fun. And then I ended on Tuesday, and then off stream afterwards ordered the boards from Osh Park. Osh Park is a great board house fulfillment service based in the US, definitely worth checking out. And excited to report the boards have been assigned to a panel and sent to the fab. That means that as we speak, they are being made, which is pretty awesome. So the boards are on their way. Fingers crossed, it would be really awesome if I have them by like next Tuesday so that we can do a little bit of soldering and assembly on the screen. If not, that's okay. We'll keep on, we can do it on Thursday, figure it out sort of whenever the right time is. So that's where we are. So now I wanted to get back to firmware today and actually keep working on the code side of this. So let me shut down Eagle and show off a couple of different things. I actually was messing with some SD card stuff. That was one piece when I built this originally. I think I had mentioned I didn't have the SD card wired up. I think I made the mistake of realizing that there was a separate chip select pin on this 2.2 inch TFT that I needed to wire up in order to get the SD card working. So I just completely didn't do that at all. Sorry, I'm checking the Twitch inspector to make sure everything is looking okay. I saw a report of some drop frames out of the corner of my eye, so I'm hoping that everything is mostly okay. Anyway, so I added support for the SD card. Originally, what I was doing in the firmware was I had this giant. That's the libraries. I had this giant, basically bitmap, black and white bitmap, or white and gray bitmap that I was using to draw something on the screen when it popped up, and I wanted to change that to actually do something slightly different. I wanted to use the actual SD card reader and get some real bitmaps on there. So that's something I actually worked on off stream yesterday and got working. So I wanted to share that really briefly. What I'm doing effectively is I'm using a library called SDFAT. SDFAT allows me to access any FAT formatted SD card if it's available in your project, which it is for mine. I'm initializing the library and then using the chip select pin, and that is the one that's wired up in the upper right hand corner there. And then the real important part that I changed the other day was printing up the splash screen. So I had a splash screen before, and here, I'll run down to that real quick. Go to definition. So for my splash screen, what I'm doing is I'm just loading this brew.bmp. This is a file, a bitmap that I created that's already on the SD card that's waiting. And then that's going to end up getting drawn out to the screen. I'll have a bit of a delay, and then I'm going to add the info, like redraw the screen with some text. And so let me show a little bit of a demo for this and actually make it big. So I'm going to hit reset. We'll let things sort of re-go, and you'll see the new and improved full color screen actually being used when it gets to it. So you'll see we now have a color image that's coming up on the screen as the camera's trying to autofocus. That waits for a second, clears the screen, and then puts that text on. So that's sort of where we are and what I finished last time. So we're going to actually start making some changes to this. My plan today is actually to spend the first hour doing some firmware updates and just sort of tweaking some things here and there. And then the second hour, I actually want to create an Azure pipeline. So actually to go into Azure DevOps and create a new pipeline project to build my firmware remotely, right? Because I have this GitHub repo for BrewBuddy. What I would really love to do is get to a point with this repo where every time I submit a PR to myself, or maybe someone else submits a PR, or I get this, or I'm ready to publish, that I can use the build pipeline to build, fingers crossed, maybe run some unit tests when we get to that point, and then ultimately release new versions of the firmware, create tagged releases with binaries, and all that good stuff. So that is the plan at this point. So let's go ahead and so this one is actually done. This is one I did off stream. If you were with me last week, I actually had a few, the piezo that I was using for the NOx sensor was really, those wires are really thin. So I just added some stronger wires on that earlier today. So we'll just have that closed for now. It's closed, good to go. Okay. So there's a few things that I wanted to do today on the software side before we actually, or on the firmware side before we actually move into the Azure pipeline stuff. One thing was to actually see if I could overlay text on the splash image. Try that piece out really quickly. So, because right now what I'm doing is I'm actually doing a clear to clear the screen, set the cursor, and then writing out this text. But I think I may actually just do the clear screen later. Set to black and white. And some of this code I haven't looked at in a little while, so I'm finding a few places I'm running across. I'm like, oh, why did I do that? I'll change it. Maybe I'm a smarter developer now than I was 2 years ago. Maybe I can fix that. So I'm going to remove the clear screen and just sort of see what happens when I rerun it again. And so to rerun it, I'm actually going to, because I'm just doing local builds on this, I'm actually going to put my device back in DFU mode, or device firmware update mode, which you'll notice when I ran this command basically to just use a certain baud rate to set it. Now I'm getting blinking yellow. So it is back in device firmware update mode. And then I can come in here and use the command palette to flash application. And I'll check this, see everything sort of stream by here on the bottom. Hopefully quick. There we go. Oh, it came down. Did it already finish? Oh no, it's still going. And then I'm going to go into big picture mode when this is done. All right, it's flashed. So let's go here. And notice it's flashing green as it's reconnecting to the particle device cloud. Waiting, waiting. It's going to draw the picture. And then put the text over the top. Ah, that's actually kind of cool. That worked like I thought it would. I want to see if that how that looks up close, because I was watching it on the screen. So I'm going to reset and watch up close. I think that actually looks kind of nice. It looks good. The contrast is there. You can actually see what's happening. You know, the other thing is I'm wondering why in the world it's clear screen. Like every time I reset, the waiting for brew message is still there from the beginning. So I want to clean that up too, actually. Make a note to myself. Oh, let me switch back here. So clear the waiting for brew message on startup. I will convert that to an issue. Dang, I'm getting some weird stability issues in the Twitch inspector today. This is not great. I don't know what's going on. I don't know if y'all are seeing some drop frames or what, but I apologize. I have no clue what's happening here today. All right. Well, hopefully things will stabilize and stay sort of normal. All right, so the overlay, the splash text on the image, that piece is done. So I'm going to remove this clear screen line. And let's check this in. Status. So overlay text on image for splash. Closes, what was that one? Number 12. And we'll push. All right. So next up, speed up the image drawing, clear waiting brew message on startup. Let's clear that startup message first. I'm wondering why. So I know this is being printed here. No, I guess I'm not calling clear screen early enough here. So let's just do that, see if that helps. All right, let me get my device back in and flash. Pretty fast here, and then we'll go to the big camera when it's done. It didn't look like it did anything any different. And now I'm wondering why I do this set color twice. To set it to black and then to white? It doesn't... Oh, that's just to set the color. I got you. That's not set text color, not fill screen. Okay, well, I don't know. I mean, I'm calling that really right after I called TFT begin, but I wonder if there's another... Oh, right, there's a frequency. Let me look at the definition for this and see. Well, that might be the best I could do. Let me try flashing it again, just in case I didn't. But it may, at that point, I think it's just sort of cached in the screen. I'm waiting to see if I see any difference this time. Still there. Well, you know what? We're calling it good. We're calling it good. All right. Let's we'll flash this one last time. And then let's start working on another piece. So clear waiting for brew on startup. Yeah. Clear waiting. Clear screen after startup. Close to number 16. Okay, push that out. Oy. Okay. So that's good. Now let's actually see about speeding up the image drawing. So we can try to connect to the TFT a little bit faster. You'll notice when it actually resets, you know, it takes several seconds to actually get the screen, to get the image drawn on the screen. So we can try to push the interface a little bit more there. Why am I getting nothing now? Crap. Bitter irony. I may have just inadvertently broken it on myself. All right, what the heck did I change? Oh, no, there it was. All right. There it was, did it to myself. Okay. Nope. 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 Wrong. There we go. So we can try to speed this up inside of the library for the screen. There are a number of frequencies. Let's see, where is the frequency? The SPI default frequency is what we're running at now because we're not passing one. So I want to see what that actually is. So and you'll see here, there's a number of different frequencies based on the hardware, the silicon that's running the microcontrollers, right? Arduino, AVR, ESP32, ESP8266, Raspberry Pi can go up to 8036. I'm tempted to try 48. Let's try 40. Because this is a new, I mean, this is a, these chips run the Nordic NRF52840, which is ridiculously fast. So, well, maybe not ridiculously fast, but. So let me see if I can, in tft.begin, push that just a little bit. And let's create our own command, define for that. Define TFT. Start with 40 and see if we can push it faster. All right. So I am going to flash. See if this, oh, realized I had the big screen on the whole time. Sorry about that. Try to go back to, remember to go back to small screen when I'm running code. I'll show that in just a second, what I just did. It doesn't seem much faster. This thing's got to stop trying to autofocus when it sees my screen. Okay, so what I did on here, inside of the library for this display, there are a number of SPI bus frequencies, defaults that are set based on the board that you're using, if it's an ESP8266 or 32. The overall default is 24 megahertz, so not very fast. I tried to push it up to 40. I think I maybe can go up to 50. Let me try to go up to 60 and see what happens. So what I ended up doing was created a defined TFT speed. And let me see if I can go up to 60. And see what that does. Yeah. I wonder if this is happening because I'm trying to push too high resolution on that desktop monitor. Sorry, a few unstable events that I'm seeing. Maybe it's just too much. You could bump down the resolution a little bit. In any case, so I changed this to 60 now, so we'll see if we can actually get it going any faster. All right, now we go, it pushed, we go to big camera mode. Yep, I'm trying to push too high res on this desktop cam. So forgive me, I'm doing this like real time. Okay, I dropped the resolution down on the camera, so maybe that'll actually fix some of the instability things. Apologize. And let's run that again. So it obviously runs at 60 megahertz, but I couldn't tell if it was any faster because I was messing with the camera. It's got a weird hiccup at the beginning. Man, that looked so much better at HD. That's all right. The camera can't handle it. All right. Oops. And now I gotta fix it here. And make it a little bit bigger. Okay. We're back in business. We're back in business. Apologize for the drops if anybody was affected by those. Try to do too much. So it can do 60. Let's live dangerously and try 80. And then, well, there's another thing I want to do and make a note for myself. So use another thing I'll show. So it'll speed us up a little bit. That'll be the next thing that I do. All right. Okay, get it back in, reflash. And when that's done, I'm going to go back into big camera mode. And then hopefully not get a drop this time. Nope. Oh no, I did get a brief one. All right. I might need to stay out of big camera mode. That feels a lot faster. I don't know if y'all are discerning the difference, but it feels faster to me. I'm gonna stay in small camera mode because I think that's causing some weirdness on my stream. It's pushing the max of my bitrate. So let's go from 80 to 120. So 120 megahertz on that screen. Might be able to make it happen. and look. All right, I think we can go with that. It is working for me. So we'll call it there, 120 megahertz. So let's check in. Frequency ups by TFT. Oh, y'all can't see that because I'm like, not that all the way down. So up this by TFT frequency to 120 megahertz. Closes. Number 11. Push that. Okay. Making progress. So the next piece I want to use to actually improve startup, you'll notice that when I'm restarting the device every time, that, I'm going to pull it back just a little bit, that the Argon is actually flashing green for a little while before it ends up breathing cyan. The green flashing basically just means that it's trying, not basically, it does mean that it's trying to connect to the Particle device cloud. And that's it. So that can take a little while sometimes it's pretty quick, but it's a blocking operation, whereas none of the other firmware is running. None of my user firmware is running until that connection is made, but it's not necessary for me to do that yet because the startup things that I want to do, it's okay for those to run. And so what I'm going to use is actually something called semi-automatic mode. So that is a system mode that allows me to say, the way that automatic mode works is that setup doesn't run until the device cloud connection is made. That's the default automatic mode. But if I do semi-automatic mode, then setup is called immediately. And then once I call Particle Connect, then it actually will try to connect to the device cloud. So what I'm going to do is I'm actually going to run in oh wait, I'm in the wrong place. There we go. Oh man. Did I do TFT speed in the wrong place? You know what? I may have need to run this again. I may have accidentally modified the generated file and not the correct file. Ugh. I swear I thought it looked faster though. Well, let's try it again. See if it blows up on me. All right, so that's fine. I do, however, want to now add in here system mode. So there is a snippet for this. I think I created a snippet for this. Maybe not. So all you do is just put system mode semi-automatic anywhere outside of setup. And when it sees that, it'll actually wait for you to explicitly call Particle.connect somewhere, which I will do that at the end of my, actually I'll do it here before Particle publish, because those publish events won't go out until I actually call Particle.connect. All right. So let's flash that again. And now what you'll see is all of the setup functionality will actually execute on my screen before the light will still be blinking green, or actually it'll be blinking white, but then it's not going to start blinking green until the screen draws, which, look at that, that actually fixed the hiccup on the startup too. So all of my startup stuff gets done. I add that. What? Oh. And then now it's going to try to make a connection. Now it's not. It's weird. It's not connecting at all. Hold on. So let me see what's going on here. If I can get some events that stream across the next time that I do this. All right, well, let me go down. So, okay, waiting for brew. And then Particle Connect. I should be calling the right thing. That's Particle.connect. Maybe I'll call this. I'll move it up. Let's try flashing that. I have no idea what's going on. So, I mean, this is the way that you are supposed to use it. Call Particle.connect whenever you're done. And my device isn't even coming online. It's not reporting itself as online. So this is not firing? What? Everything else is. Let's try it again. All right. No Particle Connect. It's frustrating. So let me try the other thing that I was going to do, which is actually to run in threaded mode. So if I do system thread enabled, I can opt in to ensure that my application loop continues to run even when the background and for all of the networking pieces from the Particle Device Cloud to actually happen behind the scenes. And I'm still getting some unstable notifications from the inspector. So I apologize if y'all are getting sort of like brief hiccups in the stream. It's really frustrating. I don't know what's going on. It's probably me. Okay, so run system thread. And I may just opt for this and then take out the semi-automatic mode piece if that's going to still be weird on me. But let's find out. All right, let's look again. Okay, I'm going to take out semi-automatic mode, leave thread enabled, and then I'll look into what's happening here later. Now, when this is done, we should still get, what's going to happen is that the connection, yeah, you'll see. The connection to the device cloud and everything happening on the screen are actually happening separately now. So that's actually ultimately what I want. My application is now running in spite of, regardless of how long it actually takes to set up that cloud connection, which is pretty nice. So we'll call that good because I like the way that it works. What was this one? Threaded mode, but so I'll go close to 17. Typo. Closes what? 17. Okay, so the next piece is adding modes for implementation, or for temperature and fermentation. What's happening right now, if I run this application, if I type start, call the brew function and click start, what that's going to do is reach out to the device. It's going to call a function on the device that changes the display to start showing the temperature. The temperature as it's read from the temperature little probe right here. And then just start a countdown of the fermentation process. And then the bottom part is a little dot graph of the temperature as it changes. So if I hold on to the end of the thermocouple, the temperature will actually start to increase. The dots will kind of start to go up. So it's a little bit of a rudimentary bar graph in there as well. So what I want to do, and then on the other side of things, I added last time this knock sensor. This little piezo that'll function as a knock sensor, and then detect fermentation before it starts. So I want to actually add some mode support in here. so that I can detect between the two, right? So right now what I have is a few different is fermenting and is active. That's basically the way that it works. So, so I'm gonna, and then you'll notice that my temperature readings are also being sent here. There's a reason for the A, B, and C thing. That's legacy. I need to fix all that as well. But it's reading those every 30 seconds? No, every 5 seconds, which is pretty frequent. So I need to drop that down. And then when you call stop, then it will switch back to waiting for brew. So looks like every 2 to 3 minutes I'm getting like weird 10-second spots of instability. Ah, it sucks. Really, really sucks. I'm just gonna keep on keeping on. I may just have to repost the video. All right, what's my, right now my temperature interval is 5 seconds. We could separate that out into intervals for reading the temperature and then intervals for, so we could get a nice graph, but then have separate intervals for posting the temperature out to the device cloud. But I'm not going to worry about that right this minute. I will make a note for myself. For reading temp and posting to cloud. And in about 12 minutes, I said that I actually wanted to switch over to the Azure build pipeline thing. So we'll see with that. We'll see. But for now, I'm going to create this and move it. So the two things that I want to do now is to change this from brew stage to having modes of some kind, right? So we have now is active and is fermenting. I want to change my is active to change all occurrences to is brewing. Did that work? Did that change everything? It didn't look like it. Oh yeah, it did. Okay. Great. All right. It's so frustrating. I don't know what's happening today. All right, so what I did for the knock sensor last week was I just added a basic check to say, hey, if it's, I'm gonna read from the knock pin. If it's over 100, then I'll detect the knock. So I have fermentation and brewing modes, but I want to change the way that these are triggered. Right now my particle function is called brew, and I want to actually change this to set mode. And we'll change this to set brew mode. And so when I go to the definition, So what I'm doing here, yeah. There's some things I added in here for like tracking IDs and things like that. I won't mess with right now. The important part is that the first command should be start or stop, but I'm actually going to change this to be to brew, and then change this to ferment. Oh wait, I'll change that to stop. I'll leave that as stop. We'll add another else. Commands. We'll just add a new command. Oh! Keyboard shortcuts getting me. Is brewing true? And then this one will actually need to be is fermenting is false. So is brewing is false and is fermenting is false. So you track when those changes happen. And then is brewing will be false here. And this is the kind of case where probably a state machine would be nice, but we'll get to that point. And is fermenting is true. And I'm going to change my heading here. This is going to be let's do, I'm going to break this up into 2 lines. Waiting for fermentation to begin. And then I notice I have some, so my return value is just a, this can return one, oh, return 0 in any case. Oh, right, that makes sense. You send a bad command, you get a 0. So we'll do a return 1 here as well. All right, so then when fermentation is begun, so this should actually work. Let me, I'm gonna go ahead and flash this. Now, when it comes back online, I should see that my function, let me clear the logs, there we go. My function has changed from brew to set mode, great. So now I can set my mode to, let's say brew for the first mode, and that should appropriately switch the screen into brew mode, great. I can do stop. It goes back into waiting for brew, and then what was the other thing I said? I could do ferment. Now for ferment, this, I have some serial commands that are actually waiting. We'll change that to actually use the screen, right? It just checks the knock valve when it reads that if I'm in this fermenting, which is where I am now. So when I mess with the knock sensor, it should do something on the terminal. Oh yeah, and I am writing to the screen as well. So I'm writing out knock detected. And I can remove this subheading line. I don't need to delay it. So those values, I mean, I didn't. I may want to calibrate that a little bit lower with some real world testing of the brew, but for now, I think that's pretty good. I can still write out the cereal, and I'm gonna say, here's what I'm gonna to keep a variable for. Did I set that already? Make sure I'm not trying to do more than one thing here before checking in code. All right, I'm gonna check this one in as modes being complete. Edit modes for brew and fermentation. What does that close? 8. So add functionality for first detection of fermentation. And then what I want to do after that is actually start to get some sense of fermentation rate. Track and display. But I'm going to save these for later. Because what I want to do when I get to fermentation mode is actually implement a sleep mode. You can actually, in order to get really low power, I mean right now I'm running off a USB, but during fermentation I would really love to run this thing off of just a LiPo battery. And so I can use sleep modes in order to help me do that. Right, and so for, let's see, for the Argon here, I can use system sleep. And there's a few different options that I have here. I can do a deep sleep mode and then wake up on an interrupt, and I can set my interrupt actually to the knock pin, which would be kind of cool. So let's do that. And I will, let's see. Where's the right place to do sleep mode? I mean, probably here in fermentation, right? So system.sleep. Make sure this is what I want to do. Oh yeah, I'm going to calibrate it. First, let me calibrate the sensor down a little bit. Here's my loop. Right. So I will say at this point, I have detected fermentation. Dakami, hey, welcome. No, thanks for jumping in. Today's been, I've had some weird stream issues. So please let me know if you're seeing anything with instability or frame drops or anything like that. I have no idea what's going on, but it's really bothered me. I did actually order the PCBs. Let me open up Eagle again, and I'll show you the final result. But yeah, I finished the PCBs on Tuesday evening off stream. It was really just some cosmetic stuff in order to get. I realized I had the grid off on Eagle, which is why I was hassling. So much stuff was hassling me. Moved some things in a bit to get the PCB a bit smaller, and it's good to go. So I ordered these on Osh Park. They've already been sent off to the fab. Fingers crossed. I hope to have them actually on hand maybe early next week, and we can start to do some soldering, assemble the boards on the stream, which would be good stuff. So, oh, cool! Thanks so much. That's really cool to hear that. I'm happy, even in the midst of me struggling placing vias on Tuesday. that you were able to take a few things away from it. So I love that. So it came out. So what I ended up doing was, because I want to have these soon, I got impatient. I did a fast order, which is not normal. These boards would come out to, the question is how much did it come out to? About $35 for 3. So that's what Osh Park will do, is they'll give you 3 boards. So if I really wanted to, I could get this even smaller. But frankly, right now, I felt pretty good about it's larger than my last iteration, but that's because the feather wing footprint is larger, and because I added the knock sensor, so I want to have enough room. I didn't want to push things in more and then inadvertently, oh crap, now all of a sudden I don't have room to put anything down on the board. So that's where we are. That's where we are right now. But yeah, I'm pretty excited. So fingers crossed. I hope to get those early next week. Either Tuesday stream or Thursday stream will do the assembly. So I'll actually solder everything together. And thank you. I appreciate that. I feel pretty happy with how it came out. So today what I'm doing is actually doing a little bit more on the firmware. So I was showing this off earlier, but I actually changed some things to where I now have, so I'm using threading mode, and I integrated with the TFT, with the SD card reader, and what? Oh, I did. There it is. Yeah, the screen was, the beer image wasn't drawing. So I actually added a bitmap to the display now, made it look a little bit fancier. So I'm reading from an SD card that's actually part of the breakout board for that Adafruit TFT, which is cool. And I verified as a result too that everything actually is connected properly. So because I hadn't really gotten the TFT working yet before I ordered the board, so I was a little bit worried I was wrong on that, but it actually turned out fine. So happy about that. Oh, y'all don't need my iTunes. Okay. Yeah, so what I'm doing now, and I also, Kami, I think you were on last week, I added some stronger wires to the knock sensor so that it's actually now, it's not falling out of the board. So that'll be really nice. I can actually use that. So now what I did was I added some modes for fermentation and brewing. And then I was doing some things to clean that up. And what I was just in the process of doing was implementing, calibrating the knock sensor a bit better, right? So now what I want to say is, where'd I go? Fermentation detected when the knock value is over 80. So I'm going to flash that again and then see what we can get from the serial monitor. And then I'm going to need to go into fermentation mode. All right. So I'm going to go into fermentation mode, and That will switch into waiting for fermentation to begin, which I just realized I want to clear the screen when that happens, because it says waiting for brew. Yep. I'll just repeat this here. Fix that piece in just a second. But fermentation mode is going, and I'm gonna tap the knock sensor and see 130. Yep, 87. That's me like physically tapping it, so probably not as light as when fermentation happens from the airlock on the carboy, the top of the carboy, but still should work. Okay. So I feel like that's pretty decent in terms of calibrating the knock sensor. We'll have to see through, like I mentioned, through some real world testing, but I feel okay about it for now. So I'm going to check that in. Number 7. Okay. Still getting those weird 10-second instability reports. So I don't know. I don't know. Did I push that? Yeah, I did. Okay. All right, now I'm going to implement sleep on this real quick, and then I'll switch over to messing with the Azure pipeline stuff, which should be fun. So for sleep mode, what I said I need to do, I think I want to go into sleep mode deep or standby. Oh, no, that's not going to work. I don't want to go sleep mode deep. But I do want to sleep on the wake up pin. So I can use any pin, and my edge trigger mode will be from low to high. I think that's what I want. So I only want it on one pin, and I'll go rising. Okay. So this is what I'm going to do. After I move into fermentation mode, so not in the loop, but in the activate here, waiting for fermentation to begin, I'll go into sleep mode here, and I will listen to my knock pin in rising mode. And I want to do this as well each time through the loop. Go back into sleep mode here. So that should work. See what happens. All right, I'm online. I'm going to set my mode to ferment. what should happen now is that, okay, that's good. So you'll notice sleep mode worked. The light went into yellow, or went to white. No, it called it. So the RGB LED went to white, which means it's in sleep mode. So I'm getting lower power readings, and we should actually check that out for real, but use the oscilloscope and check it out. It'd be kind of cool. But it's waiting for a move on the wake up. So what should happen, I don't know if this is going to work on the interrupt. We'll see if the knock sensor actually works. So all right, I don't know if sleep mode worked or not. So I think it did. Let me verify that by actually not going back into sleep mode afterwards. Just do it once. Because I think that may have actually worked as I wanted it to, like right away. And yet it was so fast going back into sleep mode that I didn't catch it. Okay. From online, I can go into fermentation mode now. So I'm in sleep mode. I actually don't think I came out of sleep mode. So let me think about this. Maybe I'm doing it wrong. Maybe it needs to be on falling. What are my options here? I think it's rising, falling, and change. Oh, change. That's what I want. That should do it. Let's try that. All right. All right. So I'm in sleep mode. Doesn't seem like I'm coming out. So I'm sure I'm doing something wrong here. That's fine. System sleep can be used to put the entire device into a stop mode with a wake up on interrupt. In this particular mode, the device shuts down the network and puts the microcontroller in a stop mode with configure a wake up pin. It probably has to be like externally brought high, right? Yeah, I mean, so the other option is that I just do it for 60 seconds or whatever. Have it wake up every 5 minutes or something along those lines. Am I on the right pin? Well, yeah. I'm reading from my knock pin. You know what I should do? I should try doing a particle publish after this and see if maybe that's the... Maybe I'm not using it wrong. Because if I'm willing to admit that there could be something about this, how this works, that I'm not understanding or not doing correctly. But it feels like that should work, to where actually the voltage change on the knock sensor should be the thing that wakes it out of sleep. That's what I want. That's what I want to have happen. All right, I'm in fermentation mode. So I want to see an event that pops up in this list when I actually knock this thing away. And it doesn't look like, could I even call a stop? Let's see, so it's disconnected. So the reason why I wanted to do this, obviously, is to have it just sleep until fermentation starts and then to pick it up and to start detecting it, right? Maybe even not go back to sleep, but just for that first 24 or 48 hours until fermentation begins, or until the rate changes. To stay in sleep mode. The other option is that I could wake up every 5 minutes. I need to mess with this a little bit more. Sleep. I mean, I can try this. But it doesn't seem like it actually woke up. Argon did not wake up from sleep. I mean, I can verify that this happened by just doing sleep result. And then print that out. Yeah. print. Oh, God. Oh my gosh. I'm messing myself all over the place. New keyboard, fail. Okay. Let's just serial this out. And serial that. And it will be reason what? Wake up reason none. See what we get there. Splash now and see what happens. If this doesn't, I mean, if it's really telling me it's not waking up, then I may just go back to the drawing board and just do a timer-based sleep mode, as opposed to trying to use the knock sensor as my wake-up pin. I don't know why that wouldn't work with any change. But I guess I got to figure that out. All right, we have switched into fermentation mode, which means we have entered sleep mode. And let's see. Yeah, so it didn't wake up. You know what though? Hold on. I had an idea. I could actually pull D0 high. Why don't I set this instead of on the knock pin? I'll set it on D0. Let's get internal interrupt. Will that work? Let's see. Let's put this on D0. And what I will do instead is when I get a value, yeah, let's do that. I will do a digital write on my D0 to high. Set it back to low at the end. And let me make sure I set pin mode in here. Oh, it's gonna be an output. Input or output? I'm not reading from it. So yeah. Output. Maybe that's the secret sauce. When I get a value, I set the wake up pin to high so that my device will come out of sleep mode. Maybe. Still don't know what to think about this. Let's see what we get. we call fermentation mode. Should be where we are. Let's see what happens here. Oh, wait. Instead of change, I have to set that to rising. And probably set D0 to low. Start in the setup. All right. Did I accidentally just pause the music? I did. All right, let's try this one more time. If this doesn't work, I'm cutting bait and moving over to Azure Build Pipelines because that'll be easier. Okay. Set the mode. Now let's see what happens. It is now waking up. Okay, I got some work to do there. But I think for the next half hour of the stream, I really did want to switch over to messing with the Azure Build Pipeline stuff. So let me take a look at my list here. Yes. So for the time that I have left here, I wanted to actually spend some time creating a build pipeline that does a couple of things. I will actually do a remote build for me. I mean, that's sort of the base aspiration is to create a pipeline that when I check in, when I submit a PR, that it will do a build of the firmware using the GCC compiler. So I'll have to get all of that stuff properly set up. But I think I'm actually going to do it using the Particle CLI. So we'll do that, set up the CLI remotely. Log in with a Particle test account that I have for Twitch, and then just sort of make sure it compiles, and then with a release that it will take the binaries and actually publish those as a tagged release in GitHub. So that's sort of the hope. I've seen other streamers, Jeff Fritz and Clarkio were both have been using build pipelines recently, so I actually wanted to do the same thing here. So we're going to call this project. I already have an Azure DevOps account, created an organization for that, so I'm going to create a project now. Let's see, brew buddy. Let's call it that. Fine. That song. Skip. All right. So, what service would you like to start with? Pipelines. Thank you very much. I would like a pipeline. No build pipelines were found. Yes, I would like to create a build pipeline. GitHub. That's where it is. All right, I have to connect, authorize Azure Pipelines, get my GitHub password, sign in, authorized, okay, and then I will select my repository. Oh, there we go, BrewBuddy. Nice, it's filtered by the last time you checked in. So that works out pretty well. Where do you want to install Azure pipelines? Yeah, Desaturator is good. Install on your personal account. All repositories. For now, let's just do it for BrewBuddy. So there's a separate authentication process. Oh man. So many sign-ins and re-sign-ins and sign-ins of sign-ins and authorizations of authorizations, and I mean, it's secure, so thanks. All right. Nice. There's some good starter ones here. Oh, look at that. C, C++ with, do you see that here? C, C++ with GCC. Nice. Well, that's kind of what I wanted. That is, well, all right. So I'm not sure that that's what I want, because there's two different ways that I could do this, honestly. The one way that I could actually do it would be to use the Particle CLI. And the Particle CLI actually has a compile command that you just compile to a directory, right? You pass in the target. So in my case, I would say Argon. You can pass in the target firmware version as well. So one approach I could take is to just npm install the Particle CLI, log in to Particle CLI, and then do this build, and then just have it be done as an OTA build. The other approach is to do a manual toolchain build. So like if you go to Particle's GitHub account, which is github.com/particleiot, and you go to the device OS repository, there are instructions for building firmware locally. There's a lot of moving pieces. You clone the repo, check out release stable, do a make clean all. You need to have the right GCC toolchain installed, and yada, yada, yada. And then you can flash via DFU util. So we could do that, but the advantage, I think, of using the Particle CLI is to my second objective with this build pipeline. What I would really, really love to do is have a version of the BrewBuddy that's always sitting online, always connected, and assigned, basically waiting to receive new firmware, to where you could actually, it sort of becomes my test device. So if I were to actually push new firmware, there'd be a separate device that could test. So like if somebody else made a change to it, I sort of would have a cloud connected device, and then using the Particle CLI not only would allow me to compile, but to actually flash to a device, even if it's under the device that's under my account, because I would give it permission to. But the Azure pipeline would be able to flash to that device, run some verification tests via events that pop up and things like that. That could be kind of interesting. So I think what I want to do is actually do a pipeline, a node-based pipeline, because I'll just do an npm install with that. So my VM image, so I was looking at this. So there are two different ways you can create a pipeline. You can use the visual designer. Let me look at this. Oh wait, what is this? New YAML pipeline creation experience. Right. So there is a, I guess I'm not seeing that. So my trigger is on master. All right, so there's got to be some docs on this to help me. In my VM image, is there IntelliSense on this? I mean, you're telling me what it is, but you tell me what my choices are. Yeah. So I can do scripts here to do different steps, right? So the next, all right, installing Node, great, that's a good step. I really would like to do this. Where's the pipeline docs? Oh, there's a link right there, docs. Cool, all right. No, come out here. All right, the YAML schema. Maybe y'all can't see this. Sorry, I'm just gonna go to I'm gonna take away my camera, my webcam, since we're not messing with the device anymore. So I'm looking at, oh wait, pool, that's what I want. Pool. Choose an available VM image. What does that mean? All right, so I'm gonna say macOS 10.13 here. Because I know that, I mean, Particle CLI works on Ubuntu as well, but I know it works on Mac. And so then run node tool, it's the steps, task, script, npm install. I don't need an npm install here because I don't have a project JSON. I am, however, going to do an npm install. Can you let me do a global install? Probably. Particle CLI. Let's just try this. What happens if I do save and run? Commit Azure Pipelines YAML to the registry. Commit to master, that's fine. I'm interested to run this for the first time. I know it's gonna fail, blow up on me. Something. Preparing an agent for the job. A secret agent. Maybe. Okay, connecting. Cool. I have done stuff with CodeShip in the past, with Jenkins as well. I haven't ever done any of this build pipeline kind of stuff with embedded projects though, so this is kind of interesting. So the trick that I'm thinking about, and this may be interesting, is I'm going to need to get credentials to log into the Particle CLI. That's an area where the Particle CLI, I can't do a build or a flash without logging in correctly. And I did see something in here about variables. Right? I thought I saw that. So I could do like hard-coded variables, but where could I get? Oh yeah, it's running and installing the Particle CLI. All right, cool. Let's see what happens. getting some npm warnings, so I'm wondering what. Hey, everything worked. I didn't really do anything, but installing the Particle CLI worked. Cool. That's great. So how do I go back and edit my pipeline again? What version of Node? Version of Node am I running right now? Kapow! Kapow is right. I mean, it's cool that it worked the first try, but I didn't really didn't really do anything. I have Node 971, and I'm fairly certain. Let me check the GitHub repo for this. IoT.particle CLI. Oh, no, you didn't. I mean, it looks like it's compatible with Node. I don't know. I want to change this to a newer version. I want to change this to Node. How about just 9x? Okay. No, let me save that. So we're going to install the Particle CLI. The next step will be log into the Particle CLI. And that's going to be the tricky part. YAML in its significant white space. Particle logging. Now, you can, in Particle login, I do believe, I thought you could with Particle login actually pass in options. Okay, yeah, so you don't have to do the challenge response thing. You can actually do username and password, right? So I could do this. Even though that's not documented, I thought that it was there. Yep. I got those comments too. All right, so this is do particle login, username, user example.com, password test. That would fail, obviously. Well, let's give this a name. Log into Particle Cli. Rock on, okay. Now, for variables, so I could do like, how do you get like secrets? Is there a way to actually get hard-coded variables in Android, or variable groups can be referenced? Because that would be cool. Create a variable group. Oh yeah, that's what I want. You want to link secrets from an Azure Key Vault as variables. See the following section of this topic. That's what I want. To include variable groups, switch to this list syntax. Okay, so what I will do at the top, does it have to be after the trigger? No, before trigger. Okay. So I can do variables. All right, if I spell it correctly. Name. Oh, how about just username, and that's going to be a string. So wait. Oh, the name of the variable, the value of the variable, and then the name of the group. Man, YAML is such a dumpster fire sometimes. Ugh. Okay. Fine. It's fine. So the name of the variable I'm really not understanding this. Yeah, show me an example. I mean, I know the group that I would want. So we'll just call these. I think I get it now. The group would be, let's see, particle secrets. Particle secrets. This example is, if there's something I'm missing here, this example is not really helping me a ton. So I give it a name of my variable, that's this hard-coded value up here. I'm just going to call it. I mean, I'm right to be confused by this, right? Stay. I would love to get this working before I need to wrap, but I'm going to keep going a little bit. Let's just call it. Fine. Remove the leading white space. Where? Under value or under, oh, under the variables themselves? Thank you. Thank you, thank you. That's right, each category's got to have its... Thank you. So then here, and then how do I reference variables? Keenan AF Sarcom, thanks for the follow. Apologize if I misspelled that. But hey, thanks for the follow. Thanks for coming in and hanging out. We are setting up an Azure build pipeline right now. I'm trying to figure out how variables are supposed to work. I don't know, .com, does this make sense to you? Like, how then do I reference the variable here? What's my replacement syntax? Do I just say particle username? Ah, I guess so. Is it going to use those hard-coded? Oh, all right. All right, I'm going to save and run, and then I'm going to go and add this variable group business. So it says to go into could not queue because they were validation errors. Well, where? Oh, I gotta add this first. I got you. All right, so new variable group. What did I say? I want my variable group name to be particle secrets. Stop. Okay, and the names are particle username, and particle password. Save. And should this work now? Click and run, we'll see what happens. Oh, it's been queued. Okay, well, let's see what's happening. Let's see what's going on. I have dummy values in there now, but I just want to make sure this works before I do anything else. An agent is ready. Connect. Come on. Being slow, agent. Is that every time I get off of there, it does that to me? This is a long wait. All right, well, while that is happening, I'm going to enter some real secrets into here. And then save them so that when this is done, I can try it for real. Hello, there we go. Oh, look, there's a cool little lock thing on here, so I can do that. Let me just copy this in. And then, check it. You can actually say, this is a secret. I don't want anybody to see it. That's cool. I don't want to save this until, why is this not running? Oh, there we go. Oh, that took a while. All right, installing node. We're getting node 9.11.2. Installing the Particle CLI. I'm really keen on this login piece. Bash exited with code 1. Well, give me the error. Okay. User credentials are invalid. So it didn't, so I've got to use some sort of, I figured, I got to use some sort of like replacement value, right? Oh, I just need to name the group. That was not obvious. That was not obvious at all. That was what was messing me up about this. Okay, okay. Let's, how do we edit the pipeline? So I don't need this. I just, oh, that's for hard-coded values and for groups. So then how do I, all right, so let's save these so we get the real values. And then how do I use a variable? Like inside a schema. Variables. Set variable. Oh, there we go. It is dollar open paren. Is that a YAML thing? I don't know. Let's save and run this again. I feel pretty good though. I think this is gonna work. So we are queued. It's doing its thing, waiting for an agent. So then the next thing that I want to be able to figure out is how I get my sources, right? Is that an artifact? Is it a build artifact? Artifacts are the files you want your build to produce. No. I want a library is a collection of shared build and release assets. No. So okay. Let me just go back to the schema. Because the next piece is I want to do something with the source, right? I want to take the folder, I want to do a particle, use the particle CLI to build. Yeah, pipeline. So within my pipeline, I want to check out. Yes. And then the next step, I don't need submodules. This should just be a pretty clean checkout. So just check out self, clean, false. That's not. So we're about out of time here. I think I would like to wait for this job to finish so that we can see if all that actually worked, and then I can worry about sort of the final pieces. We can pick this up again next week. But I feel pretty good about the build pipeline itself being set up. Because then the next step from here is going to be to actually do a build on multiple branches. That's what I was just looking at. Oh, that's if you want to trigger on feature branches as well, which yeah, could be interesting. or build on pull request. You mean, like, for instance, if I was actually doing like, there we go. If I was doing like UI testing, how would I reference in the build pipeline the test directory? Just show me the YAML. I just want to see the YAML for it. Now you're gonna show me the YAML. How do I pass parameters? No. I mean, that ultimately may be what I want. Okay, I'm installing the Particle CLI. It worked! Woohoo! We logged into the Particle CLI. So now, what we can do, if I was the get sources thing here, is run a build. That'll be the next step. Let's try that real quick. It'd be kind of fun. Let's just, I don't have anywhere to be for the next few minutes. I'll run a few minutes over and I'll try this out. Because then the next command would be to run a particle compile here with a directory. And assuming that we're at root, let's just assume we're at root and try. So then the last piece would be particle compile. Target is going to be Argon. I'm going against 090, and my path here, because this has a bunch of things, it's actually BrewBuddy firmware slash, I think I can just do BrewBuddy firmware. We'll see what it does. But that should be all I need to do. I don't think I need the trailing or the leading slash. And let's give this a name. And ultimately, I'm just going to need to make this a little bit more sophisticated to actually do some checking. Kapow again! Yes, thank you, .com. Let's get 3 in a row. Get Kapow 3 in a row, and hopefully I'll get an agent a little bit faster. Because now what I want to do is take the output from that. It's going to be in a directory called, actually that should just be at the root. It's going to create a binary, and then since this is master, we can actually just create a tagged release and go from there, right? So if I was doing like a quick starts, tutorials, I had this just a minute ago. Deployments? No, what I say? I said releases. Yeah, build release. Yeah, there's a lot here. There's a lot here I can do, which is pretty cool. But I suppose well, okay, so packaging maybe is what no, not packaging. Not NuGet. It's interesting. If I actually wanted to do a GitHub release, that's what I'm looking for. Do a GitHub release task with the source when it comes in. So that'll be a piece I can add later. All right, I will stop here because I can go on for a while. And I do have a meeting in a little bit that I'll be ready for. And I need a bio break, so I'm gonna let this agent run. I'm gonna let it do its thing, and then we'll get back to it. And we'll wrap up for the day. But this has been fun. Just as I think about, wrapping up, let me go back. We did some fun stuff with the camera. Not with the camera. I mean, with the camera may have caused some of my issues, but actually improving the screen. Before you leave, what keyboard are you using? Yes. Can you hear it? Is it like clicky loud, like too loud? I switched to a mechanical keyboard over the weekend from a Mac keyboard. And it is let me see if I can get it up to the screen. It's a Red Dragon, like backlit LED keyboard. This thing is so amazing. I love it. Dakami, I will whisper you a link to it on Amazon because for a mechanical keyboard, it's actually not crazy expensive. I actually got the keyboard and the mouse combo. You can't tell from the lights behind me. I'm kind of LED crazy, and I love having backlit keys. It's been pretty fun. You're a fan of the sound. I am too. I had no clue. I had no concept of how much of a fan of the sound that I would be. Because I've gotten so used to using Mac keyboards, and I realized I wasn't living right. Now I feel I'm pretty happy with the keyboard. It's been pretty cool. They are, I will double check. They are the built-in switches on the keyboard, but I want to say that they're actually, I think they're Cherry MX, I think, or maybe I'm thinking of another keyboard I was looking at that I didn't buy. All right, did that work? Okay, I got an error on building the firmware, which is okay. So it found the source. What was the issue? So this could be something, it looks like the command is legit. The directory is correct. So I'm good there. There may have just been an issue with some of my library includes. I'm trying to look at the, no. Build target. Ah. A reference issue. That's funny. I'm not getting that locally, but that's something I can fix. That's an easy fix, thing that I can actually fix and debug via the command line locally. Get that source checked in, and this helps because this is why we're doing this kind of stuff. The builds are working for me locally, but if someone else were to download this and try to build it, you might have a different issue. So that's why these build pipelines are lots of fun. So on that note, I'm going to end. I feel pretty good about the progress that we made today. Good enough for a triple kapow. Thank you, Doc. I agree. This is fun, and thanks y'all for watching today. Takami, thanks for jumping in with some advice. I will send you a link on the keyboard, and y'all have a great rest of the day. I'm going to go ahead and end it here, and I will see you again next week. Have a great rest of your week and a great weekend. Bye, everybody.